Hello everybody, I am Manu Rastogi and I am a physics lecturer from Sri Chaitanya Academy. Today we are going to discuss Advanced Paper 2019 Physics Paper 1. Okay, I am going to discuss question ID 337911112. The question is, in a radioactive sample, potassium nuclei either decay into stable calcium nuclei with decay constant 4.5 into 10 raised to power minus 10 per year, or into argon nuclei with decay constant 0.5 into 10 raised to power minus 10 per year. Given that in this sample all the stable calcium and argon nuclei are produced by potassium nuclei only, in the time T into 10 raised to power 9 years, if the ratio of stable calcium plus argon nuclei to the radioactive potassium nuclei is 99, then we have to find the value of T naught. So, in this question your potassium nuclei is either converted to calcium or it is converted to argon. Here let us assume that decay constant is lambda 1, here decay constant is lambda 2. Lambda 1 is given in the question as 4.5 into 10 raised to power minus 10 per year, while lambda 2 is given as 0.5 into 10 raised to power minus 10 per year. If you talk about lambda effective of the system, then you can write down as lambda 1 plus lambda 2. So, simultaneous decay. So, adding both of them you will get 5 into 10 raised to power minus 10 per year. Now, it is given that after a certain time ratio of calcium and argon. So, let us say potassium is converted to calcium plus argon. Initially at T equal to 0, N naught molecules of K was present, let us assume, and initially product was not present at all. At T equal to T, only N number of nuclei left, parent nuclei, and remaining N naught minus N are converted to product. This can be either calcium or argon. Now, ratio is given in the question. Ratio is given as 99. So, you can write down as N naught is 100 N. So, ratio of N is to N naught will become 1 by 100. Now, you can use the equation N equal to N naught e raised to power minus lambda effective into T. N by N naught you can write down 1 by 100, lambda effective we have already calculated. From here if you calculate time, then it will come out to be 9.2 into 10 raised to power 9 years. We were asked the value of T naught, and value of T naught will be 9.2, which is your third option for this question ID. So, here your options are option number 1 4.6, option number 2 2.3, option number 3 9.2, option number 4 1.15. We got here 9.2 as your answer. So, option third will be the correct answer. So, I am going to discuss here question ID 33791109, and your question is, consider a spherical gaseous cloud of mass density rho r, rho as a function of r, in a free space where r is the radial distance from its center. The gaseous cloud is made up of particles of equal mass m moving in a circular orbits about their common centers with same kinetic energy k. The force acting on the particles is a mutual gravitational force. If rho r is constant with time, the particle number density they are asking. So, here we have a cloud here. You can assume lot of particles are revolving here with same kinetic energy. Out of these particles, one particle will take which is moving with certain velocity. So, this particle is orbiting in a orbit because of gravitational force of these particles. So, if you study field at this point, this will become Gm. M will be the total mass here, total mass of the particles. Small m is the mass of one particle. This gravitational force will provide the necessary centripetal force. So, this will become mv square by r, 1 r you can cancel here. Now, since kinetic energy is constant, I will try to convert into kinetic energy. So, I will multiply and divide by 2 here. This I am writing it as k. Now, I will try to differentiate it with respect to r. Here g and small m are constant, it will become dm by dr. K is constant, so derivative of 2 kr will become 2 k, and dm you can think like dm is mass of particles present in dr thickness. So, dm you can write down as density into volume of a small element 4 pi r square dr. Here you will realize dr will cancel, and density as a function of r you can write down as k over 2 pi r square gm, and but we want to find number density. Number density you can write density upon mass of one particle. So, it will become k over 2 pi r square g m square. Now, as per your given options, option number 1 is k over pi r square m square g. Second option 3 k pi r square m square g. Third option k over 6 pi r square m square g, and fourth option k over 2 pi r square m square g, and you can check we got the fourth option. So, fourth option will be correct for this question. Okay, so we are going to discuss question ID 3379111111. In this question, a current carrying wire heats a metal rod, and wire is providing a constant power P to the rod, and metal rod is enclosed in an insulator container. It is observed that temperature T in the metal rod changes with time. Relation is given as T naught 1 plus beta T raised to power 1 by 4. Here beta is a constant, T naught also is a constant, and they are asking heat capacity of the metal. So, here let us say P constant power is there. So, in dt time P dt heat will be supplied, and this P dt heat will try to increase the temperature by dt amount. Let us say heat capacity is C and it becomes C dt. Overall you can write down as P equal to C dt by dt. Here temperature as a function of time is already given in the question. So, you differentiate it with respect to time, and one derivative is 0, it will become so this value you can put here. So, P equals to C by 4 T naught beta. Now, options they are asking in terms of temperature. So, time actually you have to convert in terms of temperature. So, this equation you can manipulate as T minus T naught equals to beta T raised to power 1 by 4. So, T raised to power 1 by 4 you can put like this. So, your power comes out to be C by 4 T naught beta T, you can write it as T raised to power 1 by 4 whole power minus 3. It comes out to be, and now C value you can write down as 4 P T naught beta T minus T naught over beta T naught whole cube. And further you can write down as 4 P T minus T naught whole cube T naught raised to power 4 beta raised to power 4. Now, options, first option is given as 4 P T minus T naught whole cube raised to power beta raised to power 4 T naught raised to power 4. Second option 4 P T minus T naught beta raised to power 4 T naught whole square. Third option 4 P T minus T naught whole square over beta raised to power 4 T naught cube. Fourth option 4 P T minus T naught raised to power 4 over beta raised to power 4 T naught raised to power 5. You can check our answer will match the first option, and the first option will be the correct answer. So, we are going to discuss question ID 337911110. Here a thin spherical insulating shell of radius r which carries a uniformly distributed charge such that potential at the surface is V naught. Here from the shell a small hole of area and charge sigma alpha 4 pi r square is made on the shell without affecting the rest of the shell. So, they are asking which of the following statement is correct. So, first option they are talking about the magnitude of electric field at the center of the shell is reduced by alpha V naught by 2 r. So, here when your shell was complete, electric field at the center was 0, but when you remove a charged particle, then some electric field is gonna created there because of the absence of charged particle. So, electric field will not reduce, electric field will actually increase at the center or everywhere within the shell. So, first option is wrong. Second option they are talking about the ratio of potential at the center of the shell to the point at r by 2 from the center towards the hole is 1 by alpha upon 1 minus 1 by 2 alpha. Let us check this option. So, initially your potential was V naught. So, you assume that q is the charge, q you can write sigma 4 pi r square, this is k q by r, this is V naught. Later a small hole is removed and charge of this hole is given in the question alpha sigma 4 pi r square. Now, let us say new potential. See, potential due to the complete shell will not change, only potential due to the small part will be removed. So, overall potential, if you write potential at the center, original potential V naught and you subtract the potential of dq charge. This is at r distance, so point charge formula you can apply k dq by r. Later dq you can write down as sigma alpha 4 pi r square divided by r. Now, you can write this value in terms of V naught from here. So, k sigma 4 pi r square divided by r you can write down as V naught. So, this will become V naught 1 minus alpha. This part will also be V naught if you take alpha outside. Now, you take a point A which is at a distance r by 2 from the hole. So, potential at A, again due to complete shell it will be V naught, but potential due to this small part will be missing here. Again you will write k dq divided by r by 2. K dq by r is already given to you, already you have calculated V naught alpha. So, 2 you can take in numerator. So, here you can write down as 2 V naught alpha, and you can check the ratio. V c by V a is V naught 1 minus alpha, V naught 1 minus 2 alpha. V naught cancels, and second option is the correct option here. Third option here. Third option, magnitude of electric field at a point located on a line passing through the hole and shell center at a distance 2r from the center of the spherical shell will be reduced by alpha V naught by 2r. See here, original electric field was k q by 2r square, but in this electric field when you prick a hole, electric field due to point charge will be missed. So, net electric field you can note down now, E naught minus k dq, and this distance is r. So, k dq by r square. Now, k dq by r already you have calculated. So, k dq by r you can write down as alpha V naught, and 1 r will be left. So, electric field at this point will be reduced by alpha V naught divided by r, but in the option it is given as alpha V naught by 2 r. So, therefore, third option is also correct, also wrong, sorry. Fourth option, potential at the center of the shell is reduced by 2 alpha V naught. Potential at the center of the shell is reduced by alpha V naught actually, that you can see here, and here it is given 2 alpha V naught. So, fourth is also the wrong option. Second option finally will be the right answer. So, question ID is 337911118. Here a thin convex lens is made up of two materials with refractive index N1 and N2. This is shown in the figure. Radius of curvature of the left and right spherical surface are equal. F is the focal length of the lens when N1 equals to N2 equals to N. Focal length is F plus delta F when N1 equals to N, but N2 equals to N plus delta N. Here it is given that delta N is very less than N minus 1, and range of N is also given. This is varies from 1 to 2. So, they are asking about correct statement. Statement number 1 is, if delta N by N is less than 0, then delta F by F should be greater than 0. Let's investigate this. So, this is your lens. Here refractive index is N1, here refractive index is N2. Radius of curvature both sides we are assuming r and r. So, focal length if you calculate 1 by f equals to n minus 1 2 by r. This will be your focal length, but when your N2 will change, focal length we are saying it will become f plus delta f, and here you can divide your lens into two parts, half lens here, half lens here. So, it will become n minus 1 1 by r. This is focal length of one lens 1 by f, and here it is n plus delta n minus 1 over 1 by r. Now, n minus 1 1 by r, n minus 1 1 by r, this again will become 1 by f. So, you can write it down as 1 upon f plus delta f is 1 by f plus delta n by r. So, here let us see delta n by n is less than 0. So, that means this is a negative quantity, and if this is a negative quantity, you are reducing something from this. So, overall this quantity, this whole quantity will reduce. If this whole quantity is reducing, your denominator will increase. Denominator will increase, that means delta f is a positive value or greater than 0 value. So, your first option is actually correct. When delta n by n is less than 0, your delta f by f should be greater than 0. Now, let us move to second option. Second option, they are saying that if n is 1.5, delta n is 10 raised to power minus 3, focal length is 20, then they are saying delta f, modulus of delta f should be 0.02 centimeter, and here we are rounding off up to 2 decimals here. So, first let us check the value of radius here. Focal length you can put 20, and you can put 1.5, and if you calculate the value of r, it comes out to be 20 centimeter. Here if we put all the values here in this equation, then f is 20, delta f we do not know, f is 20, and delta n is given in the question 10 raised to power minus 3, r is again 20. So, you take LCM here, 20 plus delta f to 1 plus 10 raised to power minus 3. So, here if you solve it with a certain approximation, your delta f will come out to be 0.02. So, your second option is also correct. Moving to third option, it is given that relation between delta f and delta n by n remains unchanged if both the convex surfaces are replaced by concave surfaces of same radius of curvature. So, here instead of convex we are taking concave surfaces, and we have to check that this relation will change or it will not change. So, first of all I will try to find relation between delta f by f and delta n by n. So, I will take f common here, it will come out to be 1 plus delta f by f and the value of r I can replace as 2f n minus 1. F here one can cancel, and here you can take it in numerator and apply binomial expansion. It will come out to be 1 minus delta f by f, and here also you can take n common. So, overall it will come out to be, so minus delta f by f can be written as delta n by n 2 times 1 upon 1 minus n. You can see the relation between delta f and delta n by n is independent of radius of curvature. So, because it is independent of radius of curvature, therefore, whether you use convex surface or you use concave surface, a relation will not change. So, third option is also correct. Right now, first option, second option, third option, all three options are correct. Now, let us check fourth option. Fourth option, they are saying that modulus of delta f by f is less than modulus of delta n by n. So, you have to check this relation, modulus by this minus sign will not affect it. Here range of n is also given to you, n varies from 1 to 2. So, now if your n varies from 1 to 2, clearly this quantity if you select, See it 1 divided by a greater quantity, this will be less than 1. So, 1 you are subtracting with some value and then multiplied by 2. So, definitely it is going to be, suppose you break the n in 2 parts. Suppose n is, in one case n is less than 1.5, in one case n is greater than 1.5, case number 1, case number 2. If n is less than 1.5, then this value will come out to be, see for a 1.5 I will check the value. It is coming out to be minus 1. So, exactly at 1.5 it is coming out to be minus 1. If you take a lesser value, then this quantity going to increase and whole quantity is going to decrease. But n, if n you are taking more than 1.5, then this value will further decrease and whole value will increase. So, you can see this value can be greater than 1, this value can be less than 1 also. So, clear cut you will not be able to say whether delta f by f is greater or delta n by n is greater. So, your fourth option is definitely wrong. Correct answer should be first, second and third. So, I am going to discuss here question ID 3379111118. Here a charged shell of radius r carries a total charge q, and phi is the flux of electric field through a closed cylindrical surface of height h, radius r, with its center same as that of shell. Center of the cylinder is the point on the axis of the cylinder, which is equidistant from its top and bottom surfaces. Now, which of the following options are correct? First option, h is less than 8 r by 5 and r is equals to 3 r by 5. Then they are saying that flux should be 0. So, this is your shell of radius r, and let us take a cylinder which just fits inside your sphere, common center, this radius is r, radius of cylinder is given to you as in option A 3 r by 5. So, this height you can calculate as, from Pythagoras you can say this should be 4 r by 5. If this is 4 r by 5, this should also be 4 r by 5. So, if you take a cylinder of height 8 r by 5, it will just fit within the shell, but in option A height is less than 8 r by 5. If height is less than 8 r by 5, then your cylinder will be within the shell. So, it will not enclose any charge, charge enclosed is 0. So, flux through the cylindrical surface will also be 0. So, first option is correct. Second option, height is greater than 2 r and your radius is greater than r. So, this time you will realize that your cylinder will completely fit your shell. So, whole charge will be inside the cylinder only. So, phi you can write down as q by epsilon 0, complete charge will be well inside the cylinder. So, second option also correct. Third option my height is greater than 2 r, but radius is 3 r by 5. So, height wise cylinder will well fit in, but radius is not that big. So, here this charge will be enclosed, this charge will be enclosed, and this will be out of the cylinder, this will also be out of the cylinder. So, I will see here how much solid angle it will subtend on the surface, and charge will also be proportional to solid angle. So, on one side if I study, then I can write it as 1 minus cos theta, and if I study this part also, because of symmetry I can simply multiply it by 2. Now, if you measure the value of theta, you can see cos theta is base by hypotenuse. Base will be this length and radius is given as 3 r by 5. So, this length is 3 r by 5, this is r, this will become 4 r by 5. So, cos theta here you can write down as base upon hypotenuse, base is 4 r by 5 and hypotenuse is r. So, cos theta will become 4 by 5. Charge enclosed you can say is q 1 minus 4 by 5, it will come out to be q by 5. Charge enclosed is q by 5, so flux should be q by 5 epsilon 0. So, third option is also correct. Fourth option mein almost similar to third option. Here radius is bigger. So, if radius is bigger, more solid angle will be there. If solid angle is more charge will be enclosed. So, flux should be more than q by 5 epsilon 0. Therefore, fourth option is definitely wrong and your correct answer should be first, second and third. Okay, we are going to discuss question ID 33791120. Here two identical galvanometers are given having 10 ohm resistance and full scale deflection, 2 microampere current. One of them we are converting into voltmeter of reading 100 millivolt range, and another one we are converting into ammeter of 1 milliampere range. Now, this instrument is used to measure voltage and current in a Ohm's law experiment, and resistance which we are using it as 1000 ohms. Now, they are asking which of the following statement is correct. One by one we are going to discuss all the options. See, first let us discuss what will be the resistance of voltmeter. So, when this galvanometer is converted into voltmeter, resistance you are placing in series. So, full deflection current 2 microampere is passed through the circuit, and you can see voltage across this will be V equal to Ig into R plus Rg. Now, full deflection current was given 2 into 10 raised to power minus 6. Voltage was given in the question that this can measure up to 100 millivolts. So, 100 millivolts I am writing as 0.1 volts, and R plus Rg you can write Rv. Rv is the resistance of voltmeter. We got 5 into 10 raised to power 4 ohms. So, in third option they are saying it as 100 kilo ohms, which is a wrong answer. Now, coming to ammeter, in order to convert your galvanometer to ammeter, you have to place a resistance in parallel with galvanometer, and since it is of the range of 1 milliampere, so 1 milliampere will pass through the circuit. Out of 1 milliampere, 2 microamperes will pass through galvanometer, rest of the current will pass through shunt resistance. Now, through the shunt resistance 1 milliampere minus 2 microampere should pass, but here we are neglecting 2 microamperes for some easy calculations. So, here 1 into 10 raised to power minus 3 into Rs equal to Ig into Rg, this because both are in parallel. So, potential difference across both of them should be same, and Rs came out to be 0.02 ohm, and ammeter resistance should also be very much close to your shunt resistance only. So, if you round it off, then resistance of ammeter will come out to be 0.02 ohm only. Now, coming to your first and second option, what is the measured value of R? So, your circuit will look like this. The voltmeter you will place in parallel across R, and ammeter you will place it in series with some battery connected. Now, this is practical value of resistance measured. Practical value you will calculate as reading of voltmeter divided by reading of ammeter. So, reading of voltmeter you can see this potential difference voltmeter will measure, you can write it as I into RRV upon R plus RV, this is resistance of this assembly, and if you measure this value it will come out to be 980.4. So, second option, the measured value of R is between 978 and 982 ohms, which is absolutely correct. Coming to first option, Now, they are saying that ideal cell is replaced with a cell of internal resistance R. Now, they are saying that measured value should be more than 1000 ohms. You can see practical value of resistance does not depend on small r. So, even if you take a non-ideal battery, then also measured value will not change. So, even first option is wrong. So, correct option should be second and fourth. So, we are going to discuss question ID 337911114. So, your question is, there is a conducting wire of a parabolic shape y equal to x square, which is moving with v naught velocity in I cap direction, and magnetic field is also given, this is varying with y, and here v naught, b naught, L, beta all are positive constants, and delta phi they are saying is delta phi is the potential difference across the wire. So, now they are asking which options are correct. Here first option is delta phi potential difference will be 1 by 2 b naught v naught L when beta is 0. So, first let us check delta phi for any value of beta. So, if you take a small element here, then delta phi you can d phi you can write down as b v into dy, and here b value you can place from here, velocity is v naught and element you have taken of dy projection along y axis. Now, while integrating it you got this answer, and if you put beta equal to 0 you will get delta phi equal to 2 b naught v naught L, and when you put beta equal to 2 you will get 4 by 3 b naught v naught L. So, that means your first option is wrong and fourth option is correct. Let us move to second option. Second option, delta phi is proportional to length of the wire projected on the y axis. You can see if you take this L out, then L is the projection on y axis, and this will be correct that your potential difference will be proportional to length projected on y axis. Third option, if your parabolic wire is replaced with a straight wire of length root 2 L, then also potential difference should be same. As you can see from the solution, nowhere we have used this equation y equal to x square. So, it will be independent of the shape of the wire, but yes, it will only depend on the projection length. So, if you are taking a length of if you are taking a wire of root 2 L length along y equal to x, then this projection is going to be L, and if projection is L, potential difference going to be same. So, even your third option is correct. Final answer should be 2, 3 and 4. Okay, your next question is with ID 337911119. So, the question is, let us consider a system of units in which mass and angular momentum are dimensionless, length has dimension L, then they are asking which of the following statement is correct. First is the dimension of linear momentum is L raised to power minus 1. Here we can say angular momentum you can write as mvr, which is dimensionless. So, m0, l0, t0 I have written. Now, r is length. So, this L you can take this side, this will become L raised to power minus 1. So, your momentum will become L raised to power minus 1. First option is correct. And now, we will also like to check the dimensions of time here for further analysis. So, velocity I have written L by t, m is dimensionless. So, you can simply remove it, and you will get that time is the dimension of time is L square. Now, power you can read, power is work done per unit time, and work done is nothing but same dimensions as that of energy. Energy I am writing it as half mv square, and mass m is dimensionless here, velocity I can write L upon t. So, velocity square is L square over t square, and this t will make it t cube, and t cube dimension can be replaced with L raised to power 6. So, L square over L raised to power 6, it comes out to be L raised to power minus 4. And finally, third option, it is talking about energy. Energy is you can write down as power into time. Power you already studied, it is L raised to power minus 4. Time already you studied L square. So, overall dimension of energy becomes L raised to power minus 2. Force you can write down as rate of change of momentum. So, momentum you can write mb, and time is t. So, mb already we have found L raised to power minus 1, time already found L square, and overall comes out to be L raised to power minus 3. If you check your options, first option is correct, momentum is proportional, momentum has dimensions L raised to power minus 1. Power dimensions I am getting L raised to power minus 4, but option it is given L raised to power minus 5. So, B option is wrong. Third option, energy dimensions I am getting L raised to power minus 2, option also L raised to power minus 2. And fourth option, force they are saying L raised to power minus 3. I am also getting L raised to power minus 3. So, your correct answer will be first, third and fourth. So, question ID is 337711117. Here 1 mole of monatomic gas is given, which is going through a thermodynamic cycle. A VT graph is given, and we have to tell the correct statements. First statement is work done in the complete cycle is 1 by 2 RT naught. So, I have divided your cycle into 4 parts, 1, 2, 3 and 4. So, in first part you can see temperature is going from T naught to 2 T naught, and volume is also going from V naught to 2 V naught. So, both are doubling. So, you can say that temperature and volume are proportional, and if temperature and volume are proportional, this has to be a isobaric process. Pressure will be constant, here volume is constant, and here again you can see here temperature becomes half and volume also becomes half. So, again V and T are proportional, your pressure has to be constant, here again volume is constant. So, in 2 parts volume is constant, straight away work will become 0. Isobaric process mein your work done will become nR delta T, here also nR delta T. Number of moles given is 1 and temperature will rise from T naught to 2 T naught. So, the change is T naught, and here temperature is going from T naught to T naught by 2. So, minus T naught by 2 is the change in temperature, and your work done comes out to be R T naught by 2. Now, second option they are asking ratio of heat transfer during process 1 to 2 and 2 to 3. See, 1 to 2 pressure is constant, so you can write your Q as NCP delta T, and 2 to 3 your volume is constant, so you can write Q as NCV delta T. So, here minus I will not take because modulus is given in the question. So, number of moles is 1, Cp by Cv I have written gamma, and monatomic gas is given in the question. So, gamma will become 5 by 3, delta T here T naught to 2 T naught, temperature variation T naught, and 2 to 3 again 2 T naught to T naught, minus not written. So, T naught cancels, 5 by 3 will be the answer. Option also 5 by 3 is written. So, second option is also correct. And third option they are asking ratio of heat transfer during process 1 to 2 and 3 to 4. 1 to 2 already calculated, 3 to 4. 3 to 4 again your pressure is constant, your Q value will become NCP delta T. Delta T here is T naught by 2. So, if you take ratio Cp will cancel and 2 will be the ratio. But in option they are saying that this ratio should be 1 by 2. So, third option is wrong. Fourth option, the above thermodynamic cycle exhibits only isochoric and adiabatic process. This statement is also wrong. This is showing isochoric and isobaric process. So, overall first option and second option will be correct. Okay, so, question ID is 337911113. Here cylindrical capillary tube of radius 0.2 mm is made by 2 capillary tubes T1 and T2, different material, and contact angle is 0 degree and 60 degree respectively, 0 degree for T1, 60 degree for T2. Capillary tube is dipped vertically in water in 2 different configurations. This is your case 1 and this is your case 2, and surface tension value, density of water, G values are given in the question. So, first option is for case 2, if capillary joint is 5 centimeter above the water surface, height of water column raised in the tube is 3.75. Here see some calculations we have done. So, if tube 1 is dipped in water, height of the water column will be 7.5 centimeter, and if tube 2 is dipped in water, then height remains 3.75 only. Now, in case 2, tube T2 is dipped in the water. So, here water can rise up to 3.75 centimeter only, and the joint is above 5 centimeter. So, tube will not be able to cross 3.75. So, height is 3.75. First option will be correct. Second case, in case 1 again your joint is 5 centimeter above. Now, they are saying that column will rise for more than 8.75. See, 5 centimeter it will rise here, here it will be able to rise only up to 3.75. It will not be able to cross 8.75 mark, that is why second option is wrong. Third option is saying the correction in the height of water column raised in the tube due to weight of water contained in the meniscus will be different for both the cases. So, if you talk about correction due to meniscus, then shape of the meniscus in tube number 1 and tube number 2 is different actually. So, if shape is different, then weight of water will also be different. So, correction will be different in both the cases. Third option is correct. Fourth option, for case 1, if the joint is kept at 8 centimeter above water surface, the height of water column is 7.5 centimeter. See, this is case number 1. If tube 1 is dipped, then water can rise up to 7.5 centimeters. So, beyond that it will not be able to rise. Fourth option is also correct. Your overall answer will be first, third and fourth. Okay, your question ID is 3379111115. In the given question, a circuit is given and there is no charge on the capacitors initially. These are two keys S1 and S2, both are open initially. C1, C2, C3, C4 capacitance are already given in the question. So, options here, option 1, if key S1 is closed and kept closed for a long time such that all capacitors are fully charged, the voltage across C1 will be 4 volts. So, if you simplify the circuit, this capacitor and battery will not participate in the circuit and your circuit will be like this, and this is a pure capacitive circuit. So, current will not pass through the resistors. So, you can remove the resistors. So, this C4, C1 and C3 will be in series and their equivalent you will get as 8 microfarad. So, charge which will pass through the battery will be 8 into 5. So, 40 microcoulomb charge will sit on all the capacitors. In the first option they are asking potential difference across C1. So, potential difference across C1 you can write down as charge on C1 divided by capacitance on C1. So, it will come out to be 4 volt. So, first option is correct. Second option, at time t equal to 0 when key S1 is closed, instantaneous current in the closed circuit will be 25 milliamperes. So, when you close the circuit at t equal to 0, potential difference across this capacitor and this capacitor will be 0 and current will pass in this circuit. So, a 70 ohm, 100 ohm and 30 ohm will be in series. R effective will become 70 plus 30 plus 100, 200 ohms and 5 volt will be the battery in the circuit. So, current in the circuit will be 5 by 200, which is 25 milliamperes. So, your second option is also correct. Third option, if key S1 is closed for long time such that capacitors are fully charged, then potential difference between P and Q will be 10 volts. See, this is your P point, this is your Q point. Between P and Q, potential difference is only because of C1. There is no potential difference across 70 ohm resistance. So, potential difference across C1 is 4 volts. So, potential difference across P and Q should also be 4 volts. In the option it is given as 10 volts. So, third option will be wrong. So, finally, your correct answer will be first option and second option. So, next question ID is 33791112. Here a block is given of 100 Newton attached with the steel and copper wires. Steel wire is of 1 meter length and copper wire is of √3 meter length. And here angle are also given 30 degree, 60 degree, and you have to find the ratio of elongation in steel to copper rod, copper wires, and Young's modulus of copper and steel both are given in the question. So, here first of all I have drawn a free body diagram here. So, there is one force mg, tension in steel cable and tension in copper cable. This angle is 90 degree here. So, mg components I am taking mg cos 30, mg sin 30. mg cos 30 will be balanced by tension in steel, mg sin 30 will be balanced by tension in copper. So, respectively they come out to be 50 root 3 Newton and 50 Newton. So, if you see elongation in copper, you can use the formula T into L divided by A into Y is equals to delta L, and same formula you apply for steel also. Divide both of them, area will cancel, tension already found out 50 root 3 in steel, 50 in copper, length is given, steel 1 meter, copper root 3 meter, and Young's modulus also given in the question. For copper it is 1 into 10 raised to power 11 and for steel it is 2 into 10 raised to power 11. When you put all the values, you will get length ratio as elongation ratio as 2. So, 2 will be the answer. So, next question is ID 3379111226. Here in the question a structure is given. Here inner refractive index is N1 and outer refractive index is N2. N1 is 1.5, N2 is 1.44. A certain length is given. Light you are passing from here, and here light must suffer some internal reflection, and finally light should originate from here. So, in the question they are asking that how much maximum time light can stay within the structure. Here theta any value you can choose. So, here if you choose critical angle, then you will realize that this hypotenuse is going to be maximum, okay, and critical angle I am going to find here. So, N1 sin C equal to N2 sin 90, and sin C I got 24 by 25. In this triangle you can see x will be perpendicular, d will be hypotenuse. So, can be written as 24 by 25 equal to x by d. Now, distance travelled, you can see if you add all the x's, then x will become 9.6. Overall hypotenuse light will travel here like this. So, light has to travel 10 meters. Now, in a medium, speed of light will decrease to c by n1, n1 is 1.5, and if you calculate distance upon speed as time taken, you will get time as 50 into 10 raised to power minus 9 seconds. Here they have written time as t into 10 raised to power 9. So, 50 should be your answer. So, next question ID is 3379111223. Here there is a moving train S1 which is moving with 108 kilometers per hour, and there is a stationary train on the platform, and then there is an observer which is moving with 36 kilometers per hour towards S2. Now, in the question they are asking about beat frequency. So, first of all, why the observer will hear beat frequency? Because one sound directly will come from S2, one frequency he will hear, another frequency he will hear from S1, and you have to apply Doppler effect twice. First, let us apply for S2 source. S2 source mein your source is not moving, observer is moving. So, observer is trying to increase the frequency. I have used the formula Fs, V plus Vo over V. Speed of sound 330, observer speed I have converted in meters per second 10. So, finally, we got frequency heard by the observer from S2. Now, from S1, see both are moving in different directions. So, you have to connect it with this line, and a component of velocity you have to take along the line joining S1 and observer. So, here this angle is 53 degrees. So, component of 10 will come 10 cos 53, and here 37 degree is there. So, component of 30 cos 37 will use here. Both will try to increase the frequency. So, numerator may have used plus sign and denominator I have used minus sign. Finally, frequency of F2 I got, frequency of F1 I got, and the beat frequency will become F1 minus F2. If I subtract both of them, then I will get 8.16 as my answer. 8.16 will be the final answer here. Next question ID is 33791121. Here a particular path is given and a force function is also given. For this force function they are asking us to calculate work done. So, this is your path given in the question. This path we are dividing in few parts AB, BC, CD, DE and EF. So, first for AB you can see y is 1 and displacement is along x direction. So, dr vector I am writing dx I cap. F dot dr if you take, then it will become minus dx and integration should be from 0 to 1. WAB you got minus 1 joules, and then BC. VC you can say x is 1 only and displacement is in y direction. So, you can write down as dy j cap and force vector you can write minus yi cap minus 2, instead of x you can write 1. So, when you take dot product you will get as minus 2 dy, and when you integrate from 1 to 0 you will get work done on VC part as 1 joule. And then CD part mein you can see y is constant. So, you can put y equal to 0.5 while displacement is along x direction. So, displacement vector you can write dx I cap. F dot dr, if you take dot product here you can see minus half dx will come and integration should be from 1 to 0.5. So, you got WCD as 0.4. Now, come to DE part. DE part mein you can see displacement is in y direction while x is constant, that is 0.5. Putting all the values and same thing again you do f dot integral f dot dr. So, work done you will get as half. Finally, comes your EO part. EO part now you can check your y will become 0 and displacement is along I cap direction only. So, this part is 0. So, x component of force is 0 and displacement is only along x component. So, work done in EF part will be 0. So, if you add all the works, minus 1 plus 1 will become 0 and 1 by 4 plus 1 by 2, 0.75. So, net work done should be 0.75 joules. So, 0.75 should be your answer. Okay, question ID is 3379111225. Here the question is, there is a liquid at 30 degree which is poured into a calorimeter and temperature of the calorimeter initially is 110 degrees. So, when you put the liquid, then it is found that straight away 5 gram of the liquid evaporates and the boiling temperature of the liquid is given as 80 degrees Celsius. So, that would mean that heat gained by the liquid will ultimately come from calorimeter and calorimeter will reduce its temperature from 110 degrees to 180 degree. Let us assume that mass of calorimeter is m and specific heat of calorimeter is S. So, heat rejected by calorimeter, here I am writing magnitude only, m into S into 110 minus 80, and this heat will be gained by the liquid. So, first temperature will rise from 30 to 80. So, 5 into S into 80 minus 30 and then it will evaporate. So, 5 L. This is your first equation. Second equation they have given that another 80 grams of the liquid is poured and then finally, it is equilibrium is maintained at 50 degrees. So, now temperature will go from 80 to 50. So, again heat will be rejected by the calorimeter, m cal into S cal into 80 minus 50 and this heat will be gained by the liquid which is poured here and 80 grams liquid is poured. So, 80 into S into and temperature will rise from 30 to 50. So, temperature change is 20, 50 minus 30. Now, from first and second you can see these two terms are exactly same. So, equating these two I finally get the ratio of L by S is 270. So, 270 should be the final answer. So, your question ID is 3379111224. Here a parallel plate capacitor is given and in parallel plate capacitor many dielectrics are placed and each has thickness of each dielectric is given d by n, where dielectric constant also they have given, it is varying with each of the dielectric m by n. Here m is the number of dielectric and capital N is total number of dielectrics and thickness of each dielectric is given as d by n. All dielectrics have same thickness here. So, here they are asking us to calculate equivalent capacitance for very large n. So, if n is very large, you can say that the thickness will be very small and you can say that almost infinite plates are there. So, I am taking here dx thickness and here let us say n dielectrics are equally placed in d thickness. So, you can say per unit width how many dielectrics are present. So, it should be d by n and similarly In x length m dielectrics are present. So, it should be x by m also, and both of them should be equal. Now, if I write a dielectric of one small plate, I can write A epsilon 0 by d, d here is dx small thickness and multiplied by dielectric constant K. Now, here since all the dielectrics are in series, so equivalent will be 1 by C1 plus 1 by C2 plus 1 by C3, or I can say integration of 1 by dc. So, 1 by dc I have to reverse it, K value I have placed here, and later m by n I am replacing it as x by d from here. M by n I have replaced with x by d. Now, you integrate it from 0 to d. Finally, you got this as, after integration you will get your C equivalent as K epsilon A divided by d ln 2. And in the question also C is given as C equals to alpha K epsilon A divided by d ln 2. So, here you can see instead of alpha you have to write 1. So, alpha value is 1 and 1 is your answer.